Welcome to RGES Algebra 2, Lesson 15B, Part 2. Now, I did have a few more ideas I wanted to cover on the graphs. We've talked about how to take an equation and put it in slope-intercept form, and the basic or the general form of the slope-intercept form is y equals something, where the first constant before the x is the slope, and the second constant by itself without a variable is the y-intercept. To graph again, this becomes 0.1, and then you move up or down and to the right based on your fraction here. So if I had negative 2/5, I would move down. I always view my negative sign with the numerator. I'd move down 2 and right 5 from 0.1. So you start with 0.1, move down 2, right 5, and plot 0.2. And then you draw a line. So that's review. Now we talked about a negative slope will go down from left to right, like this. This would be a negative slope. A positive slope would go up from left to right, like this. And two more I want to talk about would be a zero slope, now you can figure this out if you recall that m equals the change in the rise or the y-axis, okay, over the change in the x-axis. So if my slope is 0, I would have to have a 0 in the numerator. That means my y and whatever in the denominator. That means it doesn't matter how my denominator or my left to right movement goes from these 2 points, but my y value will not change. So let me give you a couple examples here. So if I have a 0 slope, it's the y value that's always going to be the same. So it's going to be a horizontal line. All horizontal lines have a slope of 0. Okay. Vertical lines have a slope of undefined. Why? Because if slope is the change in y over the change in x, and I'm on a vertical line, I'm not changing my x value, only my y value. So this is something over 0, and we're not allowed to divide by 0, so it is undefined. So let me see if there's any other things I wanted to view in this chapter 4.4. Yes, one more thing or two. The next thing would be that we talked about if you had a line, let's say I had a line here and I wanted to know what the slope was, I would just choose two that would be exactly on the graph paper. So it would be easy to read off, and maybe this is 1 square and this is 2. The vertical distance is in the numerator and the horizontal distance is in the denominator. And then, and because it's sloping up, it's positive. Okay. But what if I just gave you two numbers, like 1, 2, and -4, -2. And I said, what is the slope? Well, I would take the difference between the y values and the difference between the x values. And it doesn't matter if I go from the first point to the second or from the second to the first, but I always have to do it the same for both the x and the y. In other words, let's say I'm going to start with this point. I'd say -2, this is the y, -2 minus 2 over start with the same point for the x value, negative 4 minus 1. If I had done it from the other side, going in that direction, I would have said the y values 2 minus a negative, 2 minus a negative 2, and starting from the left point to the right point, 1 minus a negative 4. So you're always taking the difference, meaning you're always subtracting from one point to the other. If I were to simplify this, I get negative 4. Don't ask me what that other little line is there. Negative 4 over negative 5, or 4/5. And if I were to simplify the one on the right, I'd get 2 minus minus, or 2 plus 2 is 4, and 1 plus 4 is 5. So it should be the same either way, as long as you stay in the same direction for both the x value, the numerator, and the denominator. Now parallel lines, let's think about two parallel lines. Let's say there's my x and my y, and maybe line 1 is that way, and line 2 is that way. What can I say about the slopes? The slope of line 1 is equal to the slope of line 2. That should be kind of obvious. Now what about perpendicular? So if I had line 1, if I knew my slope was 7, then the slope of line 2 would also be 7. But what about perpendicular lines? Perpendicular lines are the negative reciprocal. So in a drawing, if this is x and this is y, if this were my first line, my next line would form a right angle. I don't know that looked that great, but line 2 form a right angle, okay, and it would be the negative reciprocal. So if the slope of line 1 is 7/3, then the slope of line 2, if they're perpendicular to one another, which the symbol for perpendicular would be that, okay. Line 1 is the slope of line 1 is perpendicular to the slope of line 2. Okay. Then this would be negative 3/7. So it's the negative reciprocal. Should be done with that. Now I do want to go over the quiz from this week, and I want you to all bring your corrections made to class. Okay, the first 3, you're asked to just write equivalent fractions with the same denominator. So my least common denominator here would be multiplying everything by the first one times everything by the second one. Might be easier to rewrite this as 2axy. Either way. Okay, so this is going to be a 2axy for the first fraction and a 2axy for the second fraction. What am I missing here? I have an ay, so I need a 2x as a multiplier by 2bx. What am I missing here? I've got the 2x, so I need the ay. So I've got an ay times the numerator, 3ay. Now all I have to do is simplify those. I'll get 4bx squared over 2axy. And I'll get 3a squared y squared over 2axy. And I think most of you got that. Now for this next one, I've got pretty much the same thing. My least common denominator will be, looks a little messier, but it's not really that much different, will be the z times the quantity x plus y. So that will be my denominator in both cases. my multiplier in my first fraction. I already have the z, so I need an x plus y times the numerator that's already there. And I need to do FOIL for that. Or I could actually even just leave it like it is. And in the next one, I have the x plus y, so my multiplier is going to be z times the other z. So it's going to be, simplifying this, I'll get z squared over zx plus y. Now do not go back and start canceling, because the goal here is to get the same denominators. Okay, so you won't do that. Now the third one is just the same idea, except I recognize that this can be simplified to y plus 1 over y minus 1. So I'm going to do that, identify my multiplier by each of the numerators, and then do some simplifying. Now notice here, we're really fine just like we are. We can put it just like that. We could put the a squared in the front, or leave it there, or distribute it through. It doesn't matter. Here, notice, because I took the second fraction and I already factored it, I have nothing else to add as a multiplier to my numerator, so I'll just take the numerator as is and put it down there. And then for my last one, again, I have the y minus 1, so I need the y plus 1 as my numerator times ab. I could take this part here and move it to the front. I could distribute it through, or I could leave it just as it is. Now for these next next three, I need to add or subtract. To add or subtract, you must have a least common denominator. So let's go ahead. I'm going to convert just like I did before, but then we'll have to add the numerators when we're done. Now we are going to have to multiply these, so be careful here. And for the next one, we'll do the same idea. Our least common denominator in number 5 will be ax. I do believe that most of you know what you're doing here, but I cannot overemphasize taking the time to write down the intermediate steps. You will be far more accurate if you would learn to do so. So this is a times negative 2a, so that'd be negative 2a squared, and minus 3x squared, all over ax. Number 6. Now to find my least common denominator, I'm going to factor both denominators. Whoops, it looks like I did not record that last part. So hopefully you followed this. If you got to this point, you did a really good job. You just, to get the problem correct, you need to recall that the numerator is the difference of squares. So that's that pattern that you would have had to have memorized, and then you can cancel the a minus b's. So now we'll go to the next page for the multiplication. Generally, students find this easier. Recall that this be the same as that over 1 when it's in the numerator. So just canceling out my a's, I'm going to get b squared. Now sometimes it's difficult because you get a little lost in what you've canceled. So I just like to cancel as little as possible. I'll cancel my 8's. 3 goes into 6 2 times, and I'll put that in my numerator down below. Now I'm going to count up all my a's. I have 2 up top and 1 down below. I'll be left with 1 up top. I have 1 b up top and 1 b down below. They cancel each other out. I have 1 c up top and none below, so I'll put a c up top. I have 2 d's up top and 3 d's down below. I'll have 1 d down below. And I like to do it without canceling everything because sometimes you start losing what you've done. So it's hard to see everything when it's all marked up. So that's probably the better technique. Let me go ahead and do 9 and 10 for you. Now, 9 is much different than 7 and 8. 7 and 8, we have no addition and subtraction, just multiplication, so we just cancel. Here you must factor before you cancel, so make sure you factor all 4 terms. Now that was the hard step. After that, all you do is cancel. Cancel a minus b, cancel a minus b. And now, go ahead and look at this. In the denominator for a binomial, I've got the a plus b. And now I'm just going to count the others so I don't get too confused. How many a's do I have up top? I've got 3 and 1 down below, so that'll leave me with a squared. And how many b's do I have up top? I've got 2 and 1 down below, so that'll leave me with a b. Okay. So that should be it. And then I'll do 10 for you. Now the trick to this problem is recognizing I've got 4, 2 numerators, 2 denominators, 4 trinomials that I want to factor to binomial squares. So once I do that, all I will do is cancel. So if you can cancel those, if you can factor all those accurately, then you just do some canceling. And you're left with x plus 2 over x plus 4. Now, when we get to our midterm, which we'll have not next week, but the week after, all these kinds of problems will be on it. So make sure you understand them well.